So number 10 says that for which curve shown below is f double prime positive, but f prime is negative. Now, a quick way for you to do this is just make a quick sketch of, for each graph, a quick sketch of f prime and f double prime. And for A, that would mean that f prime would be would cross over from positive to negative, and f double prime would just stay negative. So A cannot be the answer. For C, f prime is positive, so that can't be the answer. D is basically a copy of C, so that can't be the answer. And then for E, f prime is also positive, so that can't be the answer. And the only answer that you are left with is B, where f prime is negative and then f double prime is also positive. And I know that f prime is negative because, as you can see here, it is the downward sloping graph, so no matter what, f prime always has to be negative. And then f double prime is basically the slope of the f prime graph, and as you can see, it's an increasing graph, so that f prime always has to be positive. And for number 12, it says, at which labeled points are both y prime and y double prime equal to 0? So first of all, you want to know that to get y prime equal to 0, the slope of this graph has to be 0. And there are only 3 qualified points where y prime is equal to 0, and that's Q, R, and T. So you can automatically take out the answer D and A, because those slopes are not equal to 0. And so if you want y double prime equal to 0, first of all, you need to understand that this is basically looking for an inflection point where the graph is changing from either concave up to concave down or concave down to concave up. So in this case, the only reasonable answer is C, R, because Q basically just shows that it's a concave up curve because it's a local minimum, and T is a concave down curve, which is also the local maximum. Another way you can look at this question is by drawing the graph of y prime at the point R, and basically because the graph here is constantly increasing at point R, you want to draw something like a parabola where at first it's downward sloping and then upward sloping to create a local minimum here. And this basically shows that the local minimum point is R, which y double prime is also equal to 0. But for the graph y prime, it doesn't cross down to the negative side because, as you can see here, it's always increase. It continues to increase even after the slope flattens out to 0 over here.